Hi everyone. Okay, it's been a while since my last video lecture series. I'm so sorry for the delay. So anyway, right now I'm going to go outside and I want to show you something very much related with our lesson today. Okay, jom, let's go. As you can see, there's a construction going on right next door to the FKP building. That would be the new Faculty of Technology Engineering campus, by the way. So let's focus on that particular structure. It looks massive, but really, it is assembled from slender or thin members which are joined together at their ends. That thin member can either be made from wood or metal bars. So in the case of that particular structure, it is clearly made from metal bars. Looking at the shape of the structure, we can pretty much consider that it was built mainly to support the roof of the massive building. That structure is called truss, and that is the element that we want to study today. We're back inside. So in this video, we are going to cover on the chapter of structural analysis, specifically on the truss structure and frames and machines, which was made up of the principle of the truss structure. Okay, for convenience, this chapter will be divided into 5 smaller video series covering on the basic of truss structure, followed by analyzing the structure using the method of joints, and then we will look into the concept of a zero force member, and after that we will perform additional analysis using method of section, and finally the frames and machines analysis based on the principle of the truss structure. In a first glance, probably the truss structure that I showed you earlier would look like a 3D structure. But really, the structural analysis can actually be simplified into a 2D plane. If we take apart only one feature of the truss element, it forms a planar truss, which lies only on a single plane of either x and y axis, which is why the loading analysis can actually be performed in a two-dimensional space. Okay. Let's look at the truss design used to support the roof. If this is the roof, then the weight from the roof will act in a direction perpendicular to the surface of the roof. The load from the roof can then be transferred to the planar trusses. The planar trusses is this yellow colored region. Okay, so the load from the roof will be transferred to the planar trusses through a long slender member called purlins. So, if we draw the free body diagram of the planar truss only in two-dimensional view, it would look like this. So, all the external forces will be subjected to the joints of the truss. See? In this way, you don't have to perform 3D analysis for truss element. So, your life would be so much easier. Now, let us look at another structural design used to support bridges. The load from any moving vehicle crossing the bridge would be subjected to the deck of the bridge as shown. So this load would then be transferred to the stringers, which will then be transferred to the planar truss, again the yellow colored region, and it will be transferred through the floor beam. So you can observe the transition of the load from the deck to the joints of the planar truss. If we redraw the free body diagram of the loading condition at the planar truss, then this is how it would look like. Observe how the load are being subjected only to the joints of the planar trusses. One quite interesting design feature when it comes to structural design is the use of roller or rocker joint at one end of the planar truss, as shown. Certain material like metal bar will expand with the increase of temperature and it will contract with the drop of temperature. Truss structure are normally built outdoor, kan? So, the use of roller or rocker joints is being applied to compensate for that material behavior which react to temperature changes under the ever-changing weather. Okay. When we want to perform the analysis on the truss structural design, then there are 2 main assumptions that we need to consider. Okay, the first one is that we assume all the loadings are being subjected to the joints of the member, not anywhere along the slender thin member structure. Okay, usually when we perform the loading analysis, we do not consider the weight of the thin member or the slender member, because the force that the thin member needs to support is usually far larger than the weight of the thin member. So that is why its weight is being neglected in most structural studies. But however, if you still want to consider the weight of the thin machine, then it should be applied as in only half of its weight for each end of the thin member, meaning half of the weight on one end and another half of the weight on the other end. So bila you sum up these two magnitudes, it will become a total weight of the thin beam. The second design assumptions when we want to study structural analysis is that we assume the thin members are connected to one another with a smooth pin kind of connection. Okay, so recall from the previous lecture. In that way, each truss member will act as a two-force member, as in there will be one force at one end and the second force at the other end to balance it out and fulfill the equilibrium condition. Okay, so because of this, the thin members may either be subjected to a tension force or compression force. So tension force is when there is a tendency for the thin member to elongate, whereas compression force is when there is a tendency for the thin member to shorten. Okay, usually in the case of a structure being compressed, thicker member is being used to avoid the buckling effect during compression. What is a buckling effect? For example, if you apply load to each end of this thin beam, so that is a buckling effect. Looks like a bending, and it's not really good for construction purpose. Okay, as we have covered previously, the truss structure is structural features made up of thin members which are joined together to form the bigger structure. So simple truss is basically the simplest form of the truss structure. It have only 3 thin members connected at their end, forming the truss of a triangular shape. So you see the shape is very basic, very simple. This is the simplest form of the truss structure. So that is a simple truss. So of course, we can add additional members and joints to the simple truss to form a larger structure for additional support.